How's it going, guys? In this video we're going to go through our methods for adding and deleting data called enqueue and dequeue. We're also going to go through some other methods like printing, seeing if our list is empty, and other things. For me myself, I actually think our enqueuing is going to be exactly the same as our push method from stacks. The only thing that's going to be really different is our pop or our dequeue method, because with our pop in the stack, we delete from the end of the array. And with queues, right, we're going to add to the end of the array, just like with our stack, how we're adding to the end of that array, right? For the stack class, we consider the end of our dynamically allocated array as the top. Here, for our queue data structure, the end of the array is going to be the back of the queue. So when we're adding data to the back of the queue, we're adding towards the end of the array, which is exactly what we do in our stack class. However, when we are removing from the array, our stack removes from the end, but our queue will remove from the front. But honestly, you guys, the difference will be subtle. But although it is subtle, it'll be very important. Anyways, let's get started. So we have the queue class here, and I think by now when I make my print method, I'm going to be using stdcout. So I'll need to include IOStream, so that way it can use stdcout without any problems. Here we have our class defined with our private data. We have a size variable in our dynamically allocated array that's going to contain our data for our data structure. We have our good old constructors, unparameterized, parameterized, and a copy constructor, as well as our destructor and our getters. So I'm going to start with our method for adding data, which will be enqueue. It'll take a queue called value. And exactly like with the stack, if our class is empty, we're going to set size equal to 1, and our data is going to get a new dynamically allocated single variable that's initialized to our input variable value. Otherwise, we gotta assume that if our queue is not empty, then it's going to have at least one element at our dynamically allocated array. So that means we need to copy the contents, resize our array, copy the stuff back, and add our newly added value to the end of our newly resized dynamically allocated array. So we get started with that by taking a copy of the size, which I'll call data size. Then I'll have my queue data copy. Sorry if I'm using S, I'm kind of accustomed to the stacks. But here we create our new copy of what is going to be our internal data. I declare my iterator here so that we can iterate through our array, and we'll have our for loop here to iterate through everything and copy our data from our internal data to our data copy that we have here. Now that our data is copied, we're going to delete our data. Then we are going to reallocate our new size for the data, but rather than being the same size that it was before, it's going to be our size plus 1 to accommodate for our value here that we want to incorporate into our queue. So then we need to iterate through our queue data copy and copy it back. Once that's copied over, I is going to be equal to data size. Those values are going to be equal, so that way I can simply say now that data plus I is going to be equal to value, and this will let us add our array, the value that we want to add to the queue. This lets us add that value to the end of our dynamically allocated array, and we do it by resizing the array, copying its old contents over, and because now our dynamically allocated array has its original size plus 1, then right at the end of it we can slap on our value, called value, right? The variable's called value. We slap that onto the end of our dynamically allocated array, and this exhibits the same behavior as us adding to the end of the queue, right? Where the beginning of our queue is the beginning of our dynamically allocated array, and the end of our queue is going to be the end of our dynamically allocated array. So when we want to add a new value, we add to the end of our queue, which is going to be adding to the end of our dynamically allocated array. Now that this is done, we are ready to start the dequeue method. So we have, I was going to write enqueue again. So now we have dequeue. So then we're going to have a case if our stack is empty. I'm just going to make a print statement. You guys are more than welcome to, do some error handling if you'd like to. Maybe you want to throw an error. But I myself, just to keep things kind of simple, I'm just going to give a print statement that, hey, this is empty and that we're done. Otherwise, if we just have one value, then we make sure that we have our queue become empty, right? We set our variables equal to values that will let us know that it is an empty queue. So for me, I'm going to know that it's going to be an empty queue when our size is equal to 0 and our data is pointing to null. Just so that way, when we create our empty queue up above here, with our unparameterized default constructor, we do so with the size of 0 and our data pointing to null. So then, in all cases where our queue is empty, we set our size equal to 0 and our data equal to null. As you can tell with an unparameterized default constructor and our copy constructor. So now when we dequeue, we need to replicate those conditions of making our queue empty, which means that we need to set our size to 0 and we need to set our data pointer to null. In the case that it's not empty, and in the case that it is not equal to 1, well, the size of the data is not equal to 1. Here, I think it's safe to presume that our size of data is going to be greater than 1. We can't really have a size that's -1 or a negative size for a queue. I wouldn't know how that would work. But anyways, we're going to follow the same structure as we have before with our stack by taking a copy of our size. We're going to create a copy of our data. So we're going to have queue data copy. And as we take our copy of this data, I mean, here's where we're going to do the deletion. Here's where we will do the dequeuing. So I'm going to allocate data size -1, right? Because now this new data copy is going to be our new queue in which it will have our data removed. So I'm going to have my for loop to iterate from I equals 1 to I less than data size I plus plus, and then I'll copy everything, our internal data to our data copy. And because we are starting at 1, we are skipping that first value. So here's really where we do the deletion, or we do the pop, because in the previous method for iterating throughout the whole entire array, I start at 0 and I go to the end of data size. But see here, since I want to skip its first value, I start at 1 rather than 0 and I go through the whole entire array. So this essentially just lets me skip out on that first value, and I essentially dequeue it. Now there might be versions of dequeue where it will return the value where you are dequeuing, and same thing with pop. And pretty much what you can do in that case, you can say like queue, I don't know, we'll say return val can be equal to data, right? And then you can do this and dequeue everything. I mean, we can delete our data, and then we'll reallocate space for data, where data is going to be equal to a new queue, and then data size, -1, because now we've just dequeued one value, that kind of thing. And then you want to copy it back, but for this will be a full copy, so we'll have, rather than like I equals 1, we'll have I equals 0, but this time I is going to be less than data size -1. And we'll just copy everything over. So our internal data now will be data plus I is equal to data copy plus I. Ugh. And then, in this case, we'll decrement size. So I'll say size minus equals 1. And then we will delete our data copy. That should be it for the void. But if we have a return value, here's the place where we would return it if you're going to return, the value that you're dequeuing. And some stacks, some implementations can do that and some can't. And the one that I'm showing, I don't want to. I'm going to assume that you guys will be, using the front method to see what you're going to be dequeuing and that kind of thing. Right, but this is, again, just my implementation. There are many ways that people go and implement their stacks, and if you use the standard template library for the queues, or sorry, I meant queues for all that. You know, people do many implementations of stacks, many implementations of queues. You know, some people will return the stuff that they're dequeuing. Maybe we can call it like a different method name, like pop off or dequeue out or something like that, where you can return, you know, the value that you're removing. But for this, we're just removing it. We're gonna throw it away. We're assuming that it's just useless to us. And with that, we're going to continue with our other methods. We have our print method, which is going to be, well, exactly the same as our stack. So we're going to have, because here we just want to iterate throughout the entire array and print out its contents. And we'll be using, you know, std_out for this. And we'll be printing it just like if it was, I mean, just the contents of a dynamically allocated array. And then we'll be printing out a new line. Just because for this print, right, we're just printing out the values, and, you know, we want to keep things clean as we print everything out. And then our empty method, which will return a bool, is going to be exactly just as our stack, or we return the truthness of our size equal to 0, as well as our data being equal to null pointer. And actually, just because I'm accessing data directly, I'm going to access size directly. That's probably why I did it the same way in the stack. And then we'll have our linear search algorithm. So I'll need a queue and a value, and similar to this, I'm just going to copy it over. Why do all that extra work? If value is equal to data plus I, then we're going to return true. Otherwise, return false. And again, I'd use linear search just because we need to check every single value. I mean, if there's no like structure to how we organize the data within our queue, this is as good as random. So we need to check everything. Anyways, I hope here you see like the similarities between stacks and queues. And while the similarities is heavy, I mean, print, empty, and search are basically the same thing. Enqueue should be the same thing as push. And really the only difference between dequeue and pop is here. So rather in pop, we start from 0 and go until data is less than data size minus 1. But here we're starting at 1 and going until data size. Right, so for queues we go from index 1 till data size minus 1. However, with stacks we go from index 0 to data size minus 2. And that's because with stacks, we are getting rid of the last element of the array with the pop method. But with queues, we want to get rid of the first element of the array. So following the behavior that we remove from the front. Anyways, in the next video, we'll do some operator overloading, and it really should be the same as our stacks. There should be no reason why that should change too much. But anyways, just for the clarity and to be thorough for this class, I'm going to rewrite it. Thanks for watching, and I'll see you for that video.